Madam, my screen is visible.
Yes, sir, it's visible.
Okay, okay. So I think 1920s participants. So we'll wait maybe for 2-3 minutes more.
Yeah, sure, sir, sure.
Yeah. Yeah, I could see 30 has joined, 30 participants. So do you guys have any class before that? Second year students? Anyone? I could see only roll numbers. Name. Yeah, Pujita is there, and others are roll numbers. Sanjana. Okay. So what I would request everyone, instead of keeping Zoom name as your roll number, you can keep roll number and then in bracket your name also, so that it is easy for us to at least call. Yeah, I could see Vikram is there. Yeah, anyone please unmute. Do you guys have second or any class, or that class is still going?
Usually the core subjects are in the second hour, sir. So
Okay, 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 Pujita. So that second hour class is over or still going on?
for my branch, it's over. I don't know about the other branches.
Okay, okay. Okay, I think 45 has joined. Okay, so I'll ask you questions before starting this class. So what do you expect from this class? So already we have covered, right? Two classes over. So after the completion of this class, what you will understand? First, let me clear your expectations. What you will understand from this class? Anyone? Please unmute and speak. Nothing to shy. Just think this is a classroom. You are sitting in a desk, and you can tell, na, what is it? So all the subjects, whatever you are studying, try to correlate why you are studying that course. Otherwise, you will find boring courses and all the experiments will be going. If you could relate this, why you are studying this course, I don't know how it will be useful in your professional career, that experiment or that course, then it will be interesting. You will feel more excitement to study that course. So you have, I think, 5 to 6 courses in this semester, right? So out of this, one course is engineering measurements. So what you will study in this course? Any idea, anyone? Yes. Maybe last class you saw some other faculty is teaching, right? This class we too came. So you guys don't have any query like why we came last class? Some other faculty came. Yes. Anyone? Tell me, Varun. Roll number 10.
Yes, sir.
Yes, Varun. Tell me, what is your expectation from this course? What you will learn in this course, engineering measurements?
Hmm.
Yeah. So you are in second year engineering, right?
Uh, BSc Physics, sir.
Okay, BSc Physics. Anyway, you are in science domain. So what you will learn from this course?
Actually, this is my first class, so
Okay, okay. So by the name, what you understood? Measurements, right? Engineering measurements. So
I
uh,
was doing the measurements in a very precise manner, like measuring things, how to measure different things.
Okay.
different
Okay. So
level.
you were from BSc, right? BSc background.
Yes, sir.
So can you tell me what is the difference between science and engineering? Because this course is engineering, right? Written, and you are from BSc. So just I want to clarify what is science and what is the difference between science and engineering.
Application of science in engineering, sir.
Correct, correct, very good. So in the science, basically we are developing the theories, right, and algorithms and all, and the application is the engineering part, right?
Engineering. Yes,
So
sir.
science without the application is actually no use, right? If you develop equations and all, if you implement, if you do not implement in real life, then again it has no use. So that's why in this course, basically, we'll figure it out. We'll see few experiments where you can measure the quantities in a real life. So once you measure, then only you can improve the system and all. Like in cars, we have so many sensors. So what is the role of each sensor? Basically it sends some parameters. Either it may be what is the velocity in which you are going, or in some car we have right rain sensing wiper also. It will sense how if it is raining or not. Like so many sensors will be there. Basically using these all these sensors we are measuring some quantity. Either it may be velocity, wind speed, rain, whatever it may be, right? And again using these values we'll try to improve our system, or our system should be functioning. So that is the main objective. Here we'll study few measurements, basic measurements which are required and as an engineer when you are graduating. So you will find in this course in four, I think weekly 4 class we have, right, in this engineering measurement. So in each class one faculty will come, and basically they will explain the experiments from the respective domain. Like we have civil, mechanical, electrical, and electronics, right? These are the four basic engineering domains we have. And obviously you have computer science also. For that you have separate courses, computer programming 1 and computer programming 2. But in this four department we will do a lot of physical things like physical measurements, and we'll do physical constructions. If you see electronics, then you make physical chips and all. Similarly electricals, high tension cables, right? Mechanical, so many automobiles, so many production factories are there. Even for civil, if you see anywhere, if you look, you will find all the civil engineering structures, right? Roads, highways, bridges, everything. So these four are the physical engineering where you can see all the things. That's why we need to measure all the parameters. So weekly, for one class we'll have for civil, one class for electrical, one class mechanical, and one class for electronics. And in each discipline, you will study basically for 10 experiments. So here, I think course handout is uploaded in Elements. I don't know, but if it is not uploaded soon, it will be uploaded. So that's why if you see the course handout will be something like that. Although this is a draft copy, I don't know. I think final version will be uploaded within a short period. So in each discipline, electronics, we have total 10 experiments. Similarly, electrical also we have 10 experiments, mechanical 10 experiments, and from civil we have 10 experiments, right? So each day one department will take care about the respective labs. So today, that is Monday, in civil, basically we'll focusing on civil experiments. Total 10 experiments we have listed. So these are the basic civil experiments. Although when you are maybe some of you from civil, some of you from mechanical, you may ask like why we are studying civil courses although we are from mechanical background, right? Because these are the basic measurements. Although when you graduate, if you construct any buildings or maybe in automobile, all the disciplines are actually interdisciplinary in nature. So without smart structure, you cannot construct a building. Nowadays, if you go to any structures, modern structures, you will find so many sensors are attached, right? Automatic door closing, or inside airflow controlling something. So many sensors will be even in car also. Like that's why if you see in any real life, any structures or any components, it is not only single engineering discipline can make. All will be acting working together, and then the final product you will get it, right? That's why as a civil engineer or as a mechanical engineer, whatever maybe you are studying as engineering and science, you have to understand at least basics of all the parameters. What you know, then only actually you can make some critical thinkings, and all you can improve your model and all. Anyway, so in this course, maybe in this Monday, we'll discuss only civil engineering experiments. So we have listed 10 civil engineering experiments, right? So Okay, so before starting, maybe I'll ask few questions about civil engineering. So in a civil engineering, maybe some of you are from civil engineering, even maybe others also can answer. Like, what are the things civil engineers do? What are the construction civil engineers make? Yes, anyone? Please unmute. No, you say whatever you are saying. You are sitting maybe in an apartment building that's also constructed by civil engineers, right? You are moving in a car or on the road, cars are moving, so that road also constructed by civil engineers. So wherever you look, you will find something related to civil engineers: railway platforms, airport buildings, dams, irrigations. Everywhere you will find all the civil engineering structures, right? So now primarily, can you tell me what are the materials used for the civil engineering construction? Yes, I could see 140 students has joined. Please anyone unmute now and tell something. Karthik, roll number 16. So all the civil engineering structures are primarily made up of what type of material we use. You are sitting in a building, right? Building is made up, and you have beams, columns, so many things are there. So which material is used for construction of buildings? Yes. Please unmute yourself, anyone, and
So
tell.
we have some answers in chat box.
Oh, okay. I could not see that.
Cement,
Okay.
bricks,
Yes. Okay.
steel.
Yeah, fine. That's great. So now I could see, okay, so you guys are writing in a chat box. So I have to look into chat box only. Okay, fine. That's fine. So yeah, so you mentioned iron, cement, bricks. Okay, that's good. So primarily our structures are either it is concrete structure or it is steel structure, right? If you go to shopping malls or railway platforms, you will find these are structures as steel structures. Whereas flyovers, buildings are primarily concrete structure, right? So again, concrete is made up of whatever you mentioned: cement, sand, someone mentioned stones, right? Aggregates. And then we mix water. All these 3-4 components we mix together and we make our concrete. And using the concrete, basically we cast our structure, either it may be building, bridges, whatever it may be. Correct. So when you construct a structure, you have to understand the properties of concrete in details. So once you know what are the materials made up of concrete, then only you can understand, right, what is the behavior of concrete during the application of load and all, how the concrete will behave. So concrete is made up of what you mentioned: sand, cement, aggregate, and water, right? These are the 4 ingredients. If you mix together, you will get the concrete. So these are concrete is a basic material in any civil engineering structure. If you see in any and steel also, basically steel bars also we use. So that's why here we have listed few experiments which are related to aggregate here. Maybe a quartz aggregate, stones, chips, basically we are using, right? So we'll find it out. Here we have few experiments to identify the few properties of aggregates. And then we have surveying also we have to do. So before if you construct any structure, or maybe if you have you construct a road, then you have to first you have to measure, right, how much area you have, whether any hill is there on a road or it is a flat land. So all these things we have to do it, right, before any construction. So that comes under surveying. So those who are in civil engineering, maybe they will have a subject surveying. There you will find it out. Many techniques will be there to find it out, road, how to calculate the areas in a real site, all these things. So that's also here also we have few experiments about the surveying. So if you see here, I have shared my screen. So total 10 experiments are there. What are these 10? So first one is water absorption and specific gravity of aggregate, right? Aggregate is used for the concrete. Now you understood. Now you know why we are studying this code. I mean, at least this experiment, because in this experiment we'll find it out what is the water absorption and specific gravity of aggregate, right? Then next we have the shape test of aggregate. What is shape test? Aggregate, if you see it will have different size, shapes, right? So some shape will be very useful for our civil engineering purpose, construction purpose. Some shapes, for example, if the aggregate is very long but the width is very less, so in that case, that type of aggregate may not be much useful in real life construction. Similarly, sieve analysis, basically we'll try to sieve aggregates will have different sizes. Some will be small, some will be large. So again, in some construction we use large type of aggregates. If you see in a railway track, where the rail lines are placed, there all the big aggregates are big aggregates are kept there. But in your site construction where you are sitting in a building, maybe aggregate size will be less. So using the sieve analysis, basically we'll find it out which grade of aggregate is useful in which construction and all. So these first three experiments are basically more focusing on the aggregates. There we'll start understand the basic properties of aggregate. Now, because aggregate is one of the main ingredient in all the structures, whatever you are seeing. Then number fourth experiment is dumpy level. So dumpy level is used in a surveying. Means you are asked to construct a road, or maybe in a building you are constructing, you have a empty plot. So in that case, before constructing, you make the surveying in the sense you will find it out how much area is there, plain area, whether all the entire area is flat or you have some hills, anything. So basically using this dumpy level is an instrument. Basically, maybe many of you saw while where the road construction is going on, you will find many surveyors will be standing with the tripod with that camera, something setup will be there, right? I hope all of you have seen in the road construction. That is not actually dumpy level, but that is total station nowadays using, but dumpy level also similar. Yeah, some of my friends wanted to join the meeting. Yeah, you guys can join, na? I think the link is posted in the LMS. Just ask them. You have logged the meeting, or is it? 1 second. I have logged the meeting. Madam, can you just find it out? Where is the unlock option?
Yes, sir. I'll just check.
Just 1 second. I am also checking. No, it is open, I think. It is not locked, madam. Yeah, now
No,
I
sir.
think.
It's not logged.
Yeah, now I.
They can join.
Yeah. Now it is not locked actually. New participants can join. We just ask your friends to join. It is open. We have not locked anything.
Then they are joining, sir. Number has increased.
Yeah. That's fine. Okay. Yeah, 177 I could see. Yeah, I think more number. So just I will request everyone, please join on time. Maybe 10, 10-20 classes will start. Maybe by 10:22, everyone should join in the class. Okay. Yeah. So basically in this course, first 4 experiments are focused on aggregate. So you will understand what are the different properties of aggregate in these first 4 experiments. Then fourth one, first 3 experiments. Fourth one is dumpy level. Basically, I think everyone saw in a roast construction, this type of tripod will be, some person will be standing with tripod. They will be measuring something, right? Basically, they are measuring the levels that our road should be, leveled. And some portion should not be, hill, so some gradient we should maintain. So basically using the dumpy level, we are finding out the leveling part. So that experiment we'll see, number 4th. And number 5th also we have theodolite. Theodolite is also another instrument which will measure, angles, right? Our roads are not straight. If you see some portion, you will have curve, right? Right angle, left angle, some curves will be there. In that curve, we use theodolite basically to find it out how much angle that curve has made, something like that. So 4th experiment is basically, we'll find it out the height or whether it is level or not, our ground. And 5th theodolite, using that we'll find it out the angles, the roads are straight, which angle it is turned, something like that. And number 6th experiment, we have introduction to total station. So nowadays all the road constructions surveying basically is done using the total station. So earlier days, maybe 15-20 years back, we used dumpy levels and theodolite. These 2 instruments are basically mechanical instrument, whereas dumpy level is electronic instrument. That's so here we send, nowadays all the constructions, all the sites are basically using total station, where automatically you will get the elevations of site and how much angle it makes, everything. And through some laser lights they will send, and so it is more into electronics, electronic equipment, total station. Whereas theodolite and dumpy level more are mechanical in nature, so we won't use any batteries. Through eyesight we will find it out what is the elevation and all. Anyway, so these are the 6 experiments we'll do it. These are practical experiments. If you are in campus, you could have performed all the 6 experiments in our lab. Anyway, but we'll try to accommodate at least through online somehow. You guys can have some idea what is these experiments are. And then last 4 experiments are actually we introduced, these are using MATLAB. Basically, you have to find it out. MATLAB is a very common software. As an engineer, you will use lot of calculations will be there, right? You do a lot of ordinary differential equations and all you solve, right, in the mathematics class. So in this engineering also discipline also you will solve a lot of this type of equations. So by hand you cannot do it, right, in the real life structure. Maybe small ordinary differential equation you can do it by hand, but large equations you can't solve it by hand, so you need some tools to solve. So that's why MATLAB is integrated in this course. I think all the disciplines they will teach you, basics of the MATLAB. So using this MATLAB, basically we'll find it out. Civil engineering, some applications will solve it out, like computation of stresses on a body. So our civil engineering structures are what? Subjected to loads, right? Where you are sitting, maybe you are sitting in a 15-story building. On a 13th floor you are sitting. So your loads will be transferred to the slab, right? And then slab will be connected to the beam. Beams are connected to columns, and ultimately columns are resting on a foundation. That's how the loads are transferred, right? So when the loads is applied, the stresses will be generated on a body. So how much stress is generated? So that basically will small calculation will do it using the MATLAB. If a beam is there and how much stress is generated on a beam, because based on the number, based on the stresses you design the structure. If more number of people are standing on a structure, then you need very thick slab. If hardly five members are staying on a building, then you may not need very thick slab. You may need a small thickness of slab, right? So these numbers, I mean thickness of each beam, column, components and all, you will find it out, I mean based on the stresses, how much loads are coming on a structure, right? So this type of small calculations will do it using the MATLAB. And then bending moment and shear force diagrams also will do it. I think you have the course engineering measurements. No, sorry, engineering mechanics. I think you have studied first year. In this semester also you have some courses, engineering measurements or something. Engineering mechanics. Yeah, strength of material. I think you will study in the next semester. So in this course you will study the how to draw the bending moment diagram, shear force, basically moments and all. You studied in 12th standard. Know what is moment, what is force. In 12th standard physics, I think you have studied all these things. So these also will try to solve few examples using the MATLAB. And then in the last 10th experiment, basically we'll find out the deflections of beams. Means after you apply the load in a beam, how much beam will deflect, right? So that calculation also will do it in using MATLAB. So last 4 experiments will do it in a MATLAB software. We'll try to see how to write the code in MATLAB and how to solve the equations like that. And first 6 experiments will be on a physical experiment. So out of which first 3 are aggregates, and 4, 5, 6, these 3 experiments are on a surveying techniques we will study. Okay, so that's how the basic overview what you will study from the civil background, civil engineering discipline, total 10 experiments. And I think the evaluation also component total, every class, after every 2 alternative class, like this Monday we'll have 1 experiment, next Monday also we'll give 1 and 1 more experiment in civil, and then in the next Monday we'll have a small quiz of these 2 experiments, whatever we'll study in this week and next week. So it will have, I think, 1 marks. So each 2 marks. So each experiment will have 1 mark. So you will have 10 marks in day-to-day evaluation, and then you have lab record. So each experiment you have to make a report of the experiment. So each experiment will have 1 mark. So day-to-day evaluation 10 experiment 10 marks. Similarly, lab record 10 experiments 10 mark 20 marks, and I think something 5 marks will be there. Final lab component, something like that. Yeah. So total 25 from civil. Similarly, 25 marks for electrical, 25 marks for EC, and 25 marks for mechanical. So like that, I think this course is designed. Okay. So yeah. So anyone has anything to ask? Any confusion before we start our first experiment? Anything? Anyone want to ask anything? Okay. Okay. So no one has anything to ask. Okay, fine then. So in this course, basically me and Manisha madam will be taking the civil part, and other day other faculties will be teaching. Okay, so today we'll do our first experiment, that is the shape test of aggregate. That is the experiment number 2, shape test of aggregate. Okay, so we have recorded a video of we performed the experiment, and we just recorded the video. I'll just play that, and in the meantime I'll explain. I'll pause after some time and I'll explain if you guys have any doubts and all. Okay, so I'll be sharing the video. So, share screen with computer sound and the video. Yeah, so is it visible, madam?
Yes, sir, it's visible.
Okay. Okay, so it is a small video anyway. I'll just quickly explain the process. I am playing the video. Just watch carefully. Anyway, I'll post this video in the YouTube also. So, and the link will be given in the LMS. You can check after the class this video link.
Welcome to the engineering measurement
Madam, did sound came just now?
Yes, sir.
Okay, okay, fine. Just to check it. Okay, I'm playing.
Yes, sir.
course. So in this course, we'll try to demonstrate total 10 experiments which are basically from civil engineering domain. So in this lecture, we'll perform our first experiment, that is the shape test of aggregate. So before going into actual performance of the experiment, let's get started with basic understanding of what is the shape test means. So in any civil engineering constructions, either it may be highway construction or high-rise buildings, bridges, anything, we normally use the aggregate extensively. So either it may be surfacing of roads or concrete slabs, concrete columns, everywhere we use this type of aggregates. So before using this type of aggregates in an engineering purpose, we have to understand the properties of the material. So in this experiment, we'll perform the shape test of aggregate. So aggregate are actually made up of stones. So basically igneous stones are broken into small pieces and the aggregates are formed. So the surface of the aggregate may not be uniform because it is broken from the machines. So all the aggregates will have different shapes, size. So some type of particles may not be useful for the engineering applications. So such two are if the particles are very flat in nature. So each particle will have 3 dimensions. So if the particle is very thin in nature, the aggregate is very thin, then the load when applied to that aggregate, the load distribution may not be uniform. So in some cases, it will happen with the elongate particle also. So in that aggregate, few particle you will find it is very much long compared to other 2 dimensions. So so total 3 dimensions are there in any particle. So one dimension is very long compared to other two. So that type of aggregate we call it elongated aggregate. So if the aggregate is very thin, we call it flat particle, or we consider flakiness index for this type of particles. Whereas if the aggregate is very long, then we find it out the elongation index. So these two parameters are very much important to identify the shapes of a structure of a aggregate. So if again aggregate is very long, then the loads may not be acting uniformly and to the aggregate. Also the surface area of aggregate also will increase. So it will require more water, more cement paste to cover the entire surface. So this type of aggregates are not desirable in the civil engineering constructions. So if a particular type of aggregate has more number of flat particle and more number of elongated particle, then we should not use that type of particle. So in this experiment, we'll find it out how to calculate the flakiness index, basically how to find out what is the percentage of flat particle and we're to find it out how much is the percentage of elongated particle. So if any aggregate, if the percentage of flakiness, this type of material or this type of material is more than the 15% of the total aggregate, then we consider that type of aggregate we should not use for the construction purpose. So that's why before construction of using the aggregate, we should perform this experiment and we check whether the aggregate shape is below the 15%. That is flakiness and elongation index value is less than the 15%. So in this experiment, we will use these 4 types of equipments. First one is balance, which can measure up to 30 kg weight of aggregate. Then we'll use sieves. So sieves will have different dimensions. So starting from 30 mm to 6.3 mm, different types of sieve sets we need. And this is the apparatus for measuring the thickness or the flakiness index measurement. And this apparatus is used for the finding out the elongation index. So in the flakiness index, basically we are finding out how thin the aggregate is. So by definition, if whose that least dimension, that is thickness, if it is less than the 3/5 of the mean dimension of the aggregate, then we call it this is the flaky aggregate. Similar to that, if the aggregate's largest dimension, means the length, is greater than the 1/5 times the mean dimension of the aggregate, then we call it as an elongated aggregate. So these two equipments are used to find it out the flakiness index as well as the elongation index. So these are the few procedures we have to follow to find it out the shape test. First, we'll take the sample and then we'll sieve the sample, and then we'll pass each sample to the flakiness index apparatus as well as in the elongation index apparatus, and then we'll record the readings and find it out the flakiness index. So these are the observation table we'll use extensively, and then we'll fill all these values and we'll find it out the what is the flakiness index as well as the elongation index. And at last we'll publish our final outcome, how much is the total flakiness index of the weight of aggregate, and at the end what is the final outcome of the elongation index. So if these values are more than 15%, then we should not use this type of material for the construction purpose. So now gets started with the actual lab experiments.
Now we are into civil engineering lab of ICFITech building. So these are the equipments for this experiment. These are the flakiness index, then these are the elongation index measurement equipment, then some aggregates for performing the shape test, and we have the sets of sieves. So basically these are the four apparatus required for this experiment. So these sieves are kept from higher to lower end. So now we take 3 kg of sample, aggregate sample, and measure it with the balance, and you can notice that all the sieves we have kept in a sequential manner. So at the top we have the highest sieve, that is 25 mm grade sieve, and at the bottom we have 6.3 mm sieve. So once we measure 3 kg of sample, then we'll start sieving it. So now we are putting all the aggregates, 3 kg of aggregate, at the top sieve, which is 25 mm, and then we start shaking the sieves. So that all the aggregates will pass through the higher dimensions, and it will go to, and it will sieve at the bottom. So now you can see this is a 25 mm grid sieve, this is 20 mm. So how much aggregates are retaining in each sieve, that here it is shown. So in different sieve cases, different types of different weights of aggregates will be retained. So now let's take the 20 kg, 20 mm sieve where the aggregates are retained, and then we'll start our flakiness index perform. So take one by one each aggregate and try to pass it into the in that portion, that is 22. So here you can see there are many types of grids will be written. So here this sample is 25 mm passing and 20 mm retained sieves. So we'll try to pass it into that hole, and we'll record total how many aggregate passed to that sieve, and then we'll again finally make what is the total weight passed through that sieve hole, through that apparatus hole, and then we'll record that readings. So corresponding to that column we'll write that value, and then also we'll take what is the total weight retained in the 20 mm sieve. So this is the total weight retained in the 20 mm sieve. So now in each sieve we recorded two parameters. One is how much aggregate passed through the apparatus, and what is the total weight of the sample in that grade. Now this process will be repeated for all other sieves. So now we have taken next sieve, that is 20 mm passing and 16 mm retain. So now we'll take one by one each sample and try to pass it into the flakiness index appropriate holes. So one by one sample we'll take and we'll try. Now again process will be same. We'll measure the weight of how much is passing through the sieve, passing through the apparatus, and then what is the total weight, and both the values will be recorded in a table. So you can see these are the flakiness. So these are thickness is very thin compared to other two dimensions. That's why these aggregates are called flaky index. So now to calculate flakiness index, so we have how much is passing through the apparatus by the total weight into 100%. So here we just demonstrated with only two values, but in real case you have to demonstrate, you have to do for all the sieve cases. So here the flakiness index comes out to be 21.19%, which is obviously more than 15%, whichever we are considering. So now we'll start our elongation index part. So the process is very similar. We have to see first samples and all, and these are the tables. So here again 25 mm passing to 20 mm retained samples we are taking, and this is our elongation index apparatus in their respective hole where it is mentioned the 20 mm retained and 25 mm passing in their respective hole only we will try to pass the sample, and our main objective here will be how we can restrict the sample to pass. So that is we are finding out which one is the longer dimension of a sample. Now you can see each sample one by one we are taking and we are trying to retain the sample. So if it is not passing, then we are keeping it in one side. If it is passing, then we are keeping it in another side. So those who are very long aggregate, those won't pass into that hole. So that will be recorded in the separate portion. Like that for all the samples we are doing one by one. So once aggregates are retained in one side, that we are taking measurement, how much is the elongation, that is long type of aggregate, that will be recorded in a table, and then also what is the total weight of the 25 mm passing and 20 mm retained sieves, that also will be taken. So each sieve we are taking two values. One is how much is the passing and how much is the total weight in that sieve. Like that the process will be done for all the sieves, like 20 mm passing, 16 mm retained, then 16 mm passing, 12 mm, 12.5 mm retained. Like that all the sieves will be done, and the process is same. Our main objective here is how we can find it out the largest dimension of the aggregate. So aggregate should not pass here. Our main objective will be to retain the aggregate in this hole, whereas in the flakiness index our main objective was to pass the sample into the hole. So once we find it out the longer aggregates, take the weight, how much is the weight, and then it will be recorded in a table. So like that for all the samples this process will be done, and then the elongation index will be measured. So elongation index will be W1 plus W2 plus W3 by total amount of weight. So which we have recorded here, it is the value is, so here you can see 0.23 plus 0.31. So both the sieves, how much is the longer aggregate by is the total weight of the aggregate. So it comes out to be 65.5%. So the elongation index for this type of aggregate is 65.5%. So it is very huge. So like that we can perform this experiment. Thank you.
Yes, so did you guys understood? So in this experiment, basically we are using these two apparatus. Okay, yeah. So these two apparatus basically we are using, right? One is elongated index, and this one is flakiness index. Our main objective is what in this experiment? Our main objective in this experiment is to find it out the aggregate, whether it is too much long or too much thick. So using the flakiness index, the flakiness apparatus, this apparatus, basically we are finding out whether the aggregate is thin. And using this aggregate elongation index, basically we are finding out our aggregate is long or not. Okay, so that's how the experiment goes. You take the few samples, okay, approximately 3 kg, and then we have different types of sieves, right? These are the different sieve sets, starting with 20 mm. Though this first one is 25 mm diameter hole. The second one is 20 mm. Like that, many sieves we up to 6 mm thickness. All the sieves we kept it, and all the samples are kept at the top, and then we start shaking it. So once we shake it, all the small particles will go from top to bottom. It will go gradually. So at the very small particles, small aggregate will be retained at the bottom, whereas large aggregates will be stored at the top. right? So this is, we do the sieve analysis. Now we have the sieve analysis. Now if you see each sieve, how much aggregate is retained. So we have 20, right? Different sieve size are there. So yeah, so this is a 20 mm sieve, how much aggregate is retained. Next is, this is another sieve, 12.5 mm sieve, and how the maximum aggregate is retained in there. Now in each sieve we have aggregates which are retained in each sieve. Now we'll take our this apparatus. This is flakiness index apparatus. So in this in this apparatus you find there are different holes will be there. Okay, and in each fold something will be written. If you see at the top, 40 to 31.5, 12, something like that will be written. So in each sieve, like once each sieve, what is the dimension, it is written. So some aggregate will be 25 mm passing, and this is 20 mm retained. So in this last sample, if you see here, all the aggregates are actually 25 mm passing and 20 mm retained sieve. So in this appropriate hole, you will find it out where it will be written 25 mm to 20 mm. So in that respective location, you try to pass the sample. So our main objective will be how we can pass the aggregate. Pass the aggregate, one aggregate will take and one aggregate will try to pass it in that respective hole, like 20 to 25 in this hole. So then we'll separate it out. Some sample will get passed, some won't pass. So we'll make it into different portion. So this is passed and this is not passed, something like that. And how much is passed? Passed means what? These are very thin particle, where thickness is very small. That's why this aggregate got passed, right? So now that we'll take the weight, how much is passed, and we'll record in our observation sheet. So this is our observation sheet. You can see different sieve size will be there. So 63 mm passing, 50 mm retain. Similarly, 40 mm passing, 25 mm retain. So these are different sieve size. Whatever I have shown, that different sieve size will be there. So 25 mm passing, 20 mm retain. How much is the total aggregate retained in 20 mm, and how much is passed through that flakiness index apparatus? So these two values actually we are writing corresponding to each slab. So here you see, here I demonstrated with only two samples. One is 25 mm passing, 20 retain. How much is the total weight? So total weight was 1.3 kg was retained, out of which 0.36 kg is actually passed through the flakiness index apparatus. So these two values we are recording in our observation sheet. Similarly, for the 16 mm passing, 12.5 mm retained sieve, how much is the total weight? This is 1.05 total weight retained, out of which something like 0.3 or 0.4 has passed. So these two values we are recording, and we are finding out what is the flakiness index. So how to calculate the flakiness index? So this is the formula for the calculating. What is the top part? Top part is how much is passed in each sample. For example, 16 mm retained, 20 mm passing. In that, how much is passed in the flakiness index apparatus? That will be small w1. And capital W1 is the total aggregate retained at the 16 mm sieve. So at the bottom is the total aggregate, and how much is and top is the how much passed in the flakiness index apparatus. So like that, we write all the values and we'll get our final flakiness index apparatus. So anyone has any confusion? Anything want to ask? This is clear. And next we perform this elongation index. So this is the apparatus to perform the elongation index. If you see here also, it is written some values, right? 16, 20, right? 25, 20, something. So in the respective aggregate, we'll try to retain. We'll try to check whether in this hole it is passing or not. So if it is not passing, means what? The aggregate is very long. That's why this is not passing in that grade. So whoever is not passing, like that, one by one aggregate we have to take, and we have to check whether it is passing or not in the respective hole. If it is passing, then we keep it in one side. If it is not passing, then we will keep it in another side. So how much is not passing, that will give us the elongation index. Means these are the long aggregates. Okay, so again in the same table, another same table will be there for the elongation also. We'll record the two values. One is total aggregate, how much is retained in the sieve, and how much is the passing to the apparatus. And then we finally find it out what is the elongation index. The formula is same, and then we'll get the elongation index. So now the next question is, once you get the elongation index and flakiness index, what is our main objective? So if a certain type of aggregate 15% more than elongation materials are there, okay, 50, so all the, if you take 100 small aggregates, if more than 15 aggregates are long aggregate, then that type of aggregate we are not using for our construction purpose. Because if aggregate is very long, then what will happen? The load transfer or the load stress won't be uniform. Even for the absorb that concrete cement coating also, it need lot of surface areas, and load also won't transfer equally uniformly. That's why the long aggregates are not at all acceptable in our construction. Similarly, those are very thin, thickness is very small compared to other two dimensions. Those type of aggregates also not useful in the construction. So basically in these two, if these experiments if you perform, and if the flexinex index value and elongation index value is more than 15-20%, means in that type of aggregate more longer materials are there, longer aggregates are there, that aggregate we are not using for our construction. If it is less than 15% to 20%, then only we will use our in our construction. Okay, so this is a one check whether that type of aggregate you should use in your construction or not. Okay, so these are the aggregate shape tests. Yeah, so anyone has anything to ask, any confusion? Yes, please unmute yourself and tell if anyone has anything to ask. Huh? Jannavi, Pranav, Chandrasekhar, Prakash, anyone, anything, please unmute yourself and ask. Anyway, this this video will be posted in the LMS. I'll be giving the link after the class and you will get it in the LMS. And the sample data, I think it is, Madam, Manisha?
Oh, yes, sir. I have already mailed. You can check it once.
Okay, okay. So sample calculations will be given to you. I think it will be uploaded in the LMS, Madam.
Yes, sir.
Okay, so this is just one experiment data we have just shared with you, and another sample data is already prepared and it will be posted in the LMS. So you are requested to make this type of observations, calculations in your own respective batches will be there, and submit the soft copy, PDF copy in LMS itself. So we'll create an assignment for this experiment. In that assignment, once you fill all the data, all the calculations if you do, and submit the soft copy in the assignment. Okay. Yeah. So anyone want to ask, sir, can you share the lab manual PDF in LMS? Okay, fine. I'll share the lab manual also. Yes, anyone?
Sir, are we supposed to print it, write in it, scan and send?
No need to take print and all. Just the soft copy, you make it in a Word and fill all, make these tables and then fill the data and calculate it. What is the elongation index? Finally, you write it. I mean, write it in the sense, type it, and then make it as a PDF and upload it in the LMS. Okay.
Okay.
Okay. So understood the experiment. See, writing part and all is secondary. So this is for evaluation purpose. But the main objective in this experiment is you should understand the experiment. And next, why we are performing this experiment. These two concepts everyone should be clear. How to write and all anyway, that is secondary. But primary objective will be for you to understand the experiment and why we are performing this experiment. That also. So whenever you perform any experiment, first you ask yourself, why I am performing this experiment? What is the objective? I mean, once I get it, I mean, how it will be helpful in our day-to-day life, right? Okay, so anyone, anything to ask?
No, sir.
Okay. Madam, you want to tell anything?
Nothing, so.
Okay, okay, fine. I think then we are just...
They may have class next hour. I think it's already 12:10.
Yeah, it is 12:10. Now we are closing the session. Okay, so I'll be posting this YouTube video in the LMS. You can check it and submit and read also. If you online, you just search shape test, or in the reference book you will find it, the experiment. You can get more information about the experiment. What is the all these things you will get it. Okay, fine, then I'm closing the session. Thank you, madam.
Thank you, sir. Thank you, everyone.
Thank you.